And they quickly established, well, yeah, it's heaps of training data, but it's all disproportionately showing one side of this actor's face. And so that project very quickly worked out that it would be really good to be able to curate through new machine learning processes.
Welcome to How AI Happens, a podcast where experts explain their work at the cutting edge of artificial intelligence. You'll hear from AI researchers, data scientists, and machine learning engineers as they get technical about the most exciting developments in their field and the challenges they're facing along the way. I'm your host, Rob Stevenson, and we're about to learn how AI happens. Here with me today on How AI Happens is a lecturer at the University of Sydney, co-founder and contributing editor at fxguide, an Emmy-nominated veteran of the creative industry, writer, techno-futurist, podcaster, and, I have to say, general delight, Dr. Mike Seymour. Mike, welcome to the podcast. How are you today?
Good, Rob. That's such a nice introduction. I'll have to use it on my LinkedIn profile.
Oh yeah, that one's free, but the second one I have to bill at an hourly rate. But I'll let you get away with that one. Yeah, I mean, there's so many different ways we could go in this conversation just based on that bio alone. But I guess to begin with, would you mind sharing just a little bit about your background and what you're working on right now, just in case I didn't do it justice in the bio?
Sure. No, thanks. So yeah, I'm from the film industry, as you said, did many years in visual effects. I actually came up as a compositor, but along the way, I'd always had a strong academic connection. I'd done various degrees and I culminated in doing my PhD in digital humans. At that point, thought it was a really good idea to take a lot of tech that we were seeing in the film industry and see how we could research it further and do work that was both relevant to what we like to refer to as M&E, media and entertainment, but also outside that. So I have a lab where I do research at Sydney University and I also do consulting. And so they call me an engaged researcher, which means we do a lot of work with industry. And I guess I'm most well known for co-founding fxguide, which has been a bridge between academia and practitioners now, for more years than I care to remember, I think going back to 1999.
That bridge between researchers and practitioners is a well-trod one. It's common I meet people who kind of have one foot in each camp. Why do you think that is particular to this space?
I mean, it's a very rewarding place to be because when I used to be a compositor in an expensive suite, charged out by the hour, we'd have clients come in and they'd be really enthusiastic to be doing work with us, but they'd be like, hey, I want to do something really original and new. And like, what have you, seen that's like, or maybe like you could explain, like, I've seen this thing and like, how does that work? And we'd all sit there quietly, like nodding, but privately saying to ourselves, how the heck would we know? We're never allowed out of the room. I mean, we charged out at a billing rate that means they don't even want us to leave to have lunch. So it was an imperative back then to find a way to help those senior industry folk keep current and understand what was going on. Because of course you expect somebody in that position to understand behind the tech what's actually happening. But that takes time to do. So that's how that started. And then these days, I've got to say it's incredibly rewarding because I love doing research. I also like teaching. And so it's a great position to be in. But both for the teaching and also for the research, it's great to be still doing work in industry because then you know that your research is relevant and hopefully helping people. And students love having that perspective of the real world, not just a kind of, as they say, an academic point of view, but actually being able to speak from experience.
Yeah, really, really important. And when I think back to my own education, the individuals teaching me had not been in the industry that they were teaching in for some time. And it didn't stick out to me as a 19-year-old in undergrad, but it does now, right? That when I graduated, my experience was very different than what they were telling me because, of course it was. They hadn't actually done the job in a long time. So I imagine that gives you an air of credibility. What are you lecturing on at the moment?
So I do a lot of work around what we'd call digital disruption. So like that's how new processes happen. Obviously, it's in the tech space. And then also project type work, because obviously being in the VFX industry for so long, it was just, years, if not decades of just project after project after project. And, media and entertainment's a huge industry. So at the undergraduate level, that's what I'm basically teaching. And then my research is very specifically on, as I say, digital humans. So either CG or neural rendering, call it machine learning or AI. We call it neural rendering, inferring digital humans as opposed to traditional CG approaches.
Can you share what you mean by inferring digital humans?
Sure. I mean, as I'm sure your listeners will know, because, this is a really good engaged podcast, instead of doing a modeling, texturing, lighting, and rendering process to produce an output, we infer from a statistical inference based off a GAN or other machine learning techniques, the final output, which is a very different process than has traditionally been the case in visual effects. So it's interesting, like if you actually go back about 25 years, almost exactly, there was the first image-based modeling, image-based lighting approaches coming out of Berkeley and then USC with work in particular by Dr. Paul Debevec. And so that was what fed into the Matrix and all the stuff that was done in the Matrix films, this idea of sampling the real world. But since then, there's been these two kind of concurrent paths. One where you try and solve the lighting equation and come up with a really good kind of Monte Carlo sampling, ray tracing kind of thing, which is all a mathematical simulation of the real world and trying to model light. The dominant model, if you like, for Pixar, do great work, terrific. And then there's this other world where it started out, as I say, with image-based lighting and sampling in the real world. And then it's since maybe the last 3 or 4 years in particular in the film industry suddenly embraced machine learning as a way of continuing that tradition, although from a whole new perspective, which is, hey, rather than me try and model this thing, let me get the computer to get training data and come up with an inferred solution.
So the inferred solution in this case is a platform, maybe is a bad word, a technology referred to as PLATO. And I'm going to put a link in the episode description to this demonstration in a Polish film called The Champion, where PLATO was used to auto-render between English and German. And it really blew my mind when I saw it for the first time. It's fantastic. I would encourage people to check that out just so they get a little bit of a context of what we're speaking about here. But I'm curious if we can get into the development process for PLATO and if you could speak a little bit more on where that came from and how it was used in The Champion.
Yeah, absolutely. So Daryl Marks is a visionary producer who set up Adapt. That's how I came to be involved in the project. He approached me as a kind of a digital human expert to say, hey, in Daryl's words, he's always wanted to make foreign films more accessible to an English-speaking audience. And the problem is that while we can do subtitles and while we can do dubs, neither of those two things really address the issue that you can be sort of taken out of the film if you're trying to just appreciate the acting performances. Now, of course, we don't want to replace subtitles because the hearing-impaired community desperately obviously want subtitles. And quite frankly, if you're learning another language, it's a great thing to do. But in parallel to that option of having subtitles, wouldn't it be nice if I could actually see the film delivered in my native language? And so Daryl set up a company and a whole team that I'm part of to go down that path. Now, that path is basically saying, instead of dubbing the film where we just change the audio, but the vision remains the same, and we kind of hope that the lip sync doesn't look too bad and it doesn't look too hokey or embarrassing, what if we actually change the audio to English and all the mouths so they're also speaking English? And so, as you correctly pointed out, the film The Champion, Polish film about a member of the Polish community who was very early into Auschwitz in the Second World War. But this character, who's based on real life incidents, what happened, Teddy was a boxer. And so he boxed in Auschwitz. So in that film, which is incredibly moving and really great dramatic performances, what we wanted to do is convert the whole film. So every character, be them a German guard or an inmate in Auschwitz, was speaking in English so that that film would find a wider audience. Now, of course, we had to record the audio of them saying in English, but we also had to get, for every face in every shot that was speaking, we had to do an inferred or machine learning solution so that, if I can, Rob, you don't mind using you as an example. Imagine you're in the film, you're this Academy Award-winning actor, and I should say the actors in this film were really good. I mean, just outstanding. So, Rob, you're giving this terrific performance, but unfortunately you don't speak English, and I do. So we would film me just in a normal sound booth and without dots on my faces, without head-mounted cameras, I'd deliver the lines like I would in a normal sound booth with pretty standard lighting. And the machine would study my face, would study your performance, and then it would change your performance to be mouthing the words the way that I said them. And of course, then my voice would be effectively coming out of your mouths. Though, absolutely, that's how it worked. But in the case of The Champion, we also wanted to be respectful to the actors. And because, like, for example, Teddy, the lead actor, he's just a spectacular actor. He's kind of like I don't know, the De Niro of his Polish kind of community. He's really outstanding, very, very respected actor.
Peter Glowacki, I believe, is his name.
Exactly. And half that cast, including him in that lead role, came back to re-record their own lines in English. So the process doesn't require the same actor to deliver their own same lines. But of course, Rob, if you were able to speak English as well as German, it would be common sense to get you to come back and do that because, hey, you made those acting choices and we'd welcome your input again. So yeah, in the film, half the actors are the original actors come back to just revoice themselves, half aren't. In the film, hopefully, when you watch it, it's indistinguishable that it wasn't actually filmed in English. So for a really production-based budget, schedule, and approach, in other words, not as a sort of a test, not as a demo, not as a proof of concept, we converted the entire Champion from Polish to English.
So in this case, it was the original actors performing in additional languages and then using that for the auto-dubbed version. Is that correct?
Yeah, so there were I think 20 speaking parts. 10 actors that gave those re-performances were from the original cast and 10 actors weren't. And they ranged from kids to women, men. They even had Teddy with heavy prosthetic makeup because he's a boxer. And so we have scenes where his face is incredibly bruised and beaten up and swollen. And of course, we never did anything to the same actor doing that in the sound booth. He just came in that day normally. We didn't apply anything special to him, but it very convincingly produced the beaten up Teddy performance now in English as it had done previously with all the other cast.
Would the goal, medium to long term, be that the actor wouldn't need to come and perform in another language, that it could be the way you put it, where I'm the actor, but you are able to provide the English version?
Yeah, I mean, there are a couple of considerations here. At this stage, it matters, of course, that we would believe that the voice that is coming out of your mouth is plausibly your kind of age, your kind of temper. So if I was a heavy set individual, my voice would normally sound differently than if I was a cyclist or an athlete that wasn't heavy set. So it's not a machine learning problem. It's just a sort of a plausible voice problem. Yeah. And so if I was, for example, Japanese with a Japanese accent and I was trying to voice in English, I would still have my accent and that would be maybe odd. So yeah, you want to cast somebody that is plausible for the voice. You can cast anyone you like, but of course, if you can use the original actors, why wouldn't you? Because they understand the roles very well.
Of course, yeah. And as you said, they make acting choices, right? So they would want those choices to be consistent across various markets, right? They would want their decisions to be the same in whichever way they were presenting, whichever language they were presenting the film. Which interestingly, this process, I don't believe is necessarily a snag because ADR, which I forget what it stands for, but it's actors kind of after they've filmed, go and re-record dialogue so that it sounds better if on-set mics didn't pick it up. This is an existing process that actors go through and that is common in the film industry. So my point is, if someone were trying to critique this, they might say, oh, well, now you've got to have this actor come in and perform it in all these languages, but that doesn't necessarily different than what they're doing already.
No, Rob, you're absolutely right. ADR or audio dialogue replacement is incredibly standard. So on almost any major feature film you'll get the actors coming in and voicing their own lines in the same language that they did it originally, just because, yeah, as you say, there might be odd background noise or they want a different miking. Like right now, you and I are speaking to each other with our microphones quite close to our mouths, something you just can't do on set because obviously it'd be in shot. So the miking on set is always going to be sort of a different type of microphone recording than you can achieve in a sound booth. So for a whole lot of reasons, people do ADR. But yes, if that actor is able to speak in another language, you could get them to revoice themselves. If they can't, yeah, you could get somebody else to do it, which is no different than the dubbing market where we already, dub. But there is one huge advantage in the process, apart from the obvious that they look better and they are in lip sync, which is if you think about it, if I was delivering some dialogue and you wanted me to be revoiced but not have my face changed, in other words, just a normal old-fashioned dub, you'd kind of want the words that are coming out to be the same duration and kind of the same length as the original English words, because that's when my lips are moving. Now, it's not going to match perfectly, but clearly you don't want to have audio of dialogue continuing when my mouth is shut. So in fact, you actually have to compromise the translation of the script to try and coerce it into being words in that foreign language that kind of fit with the lip movements, or we call the visemes, the lip movements of the actor. So the script translation is far from a creative process where you're, in this language, the new language, we're trying to come up with the right sentiment, the right intent of the actual authors. Instead, we're trying to come up with something that's just timing to the lip movements of the actor when they first said it. Now, that's a compromise that's pretty hard to take. In our process, it doesn't apply, because if you were saying in 4 words what I'd said in 3, it would just match. We don't have to match for timing. We don't have to match for lip movement or jaw movement. It all gets fixed. So we can do a more authentic translation of the script, more in keeping with what the scriptwriters had intended, and hopefully also allowing the actor to be a little more flexible in where they take a breath, their timing, and just the emphasis on a word. Because, as I'm sure you'd know, Rob, you can say anything and punch a particular word in a sentence to give a kind of particular meaning, a slant. And that kind of meaning beneath the words is what we call the subtext of the scene. And that's gold for an actor, getting the subtext right. They can be saying one thing and meaning another. And a lot of that is conveyed by their face, and a lot of it's also conveyed by the tone of their voice, what words they're emphasizing, minor hesitations, just really subtle acting stuff. And we don't want to step on all that. We don't want to be heavy-handed in stopping the scriptwriters or the actors from being creative.
Is this a natural language processing challenge, or is this more of a creative filmmaking challenge? Both, I suppose?
There is no need for us to do natural language processing in a strict kind of machine learning sense, because the rewriting of the script is done by a person. Like you get the script writers to do a translation, and there are specialists that obviously work in that area. So we're just giving more flexibility to those people that are doing the English from Polish translation to be accurate. And in our case, the director could speak both English and Polish. So he would read the English script and say, it'd be great if he could add an extra word here because we're really not getting the intent of the original Polish. That's just people. But there's a huge amount of machine learning that goes into making sure that we read, I think in my example, my face when I'm giving the sound booth, read your face from the performance. And there's one other huge criteria I'd like to flag, which is if we're doing this as a test, you and I are in a lab somewhere, I could record heaps of training material of you, heaps of training material of me, and do a standard kind of approach and fuss with it and work with it for as long as it took to pull it off. Not a problem. It's not easy, but it's not problematic. In the case of what we're doing with the PLATO process through ADAPT is we're trying to give a production solution to the industry. And what does that mean? It means that you could deliver a finished film where we had nothing, no considerations, no extra footage, no outtakes, no B-roll, no second version, nothing but the finished film. And we would be able to convert that film. So we wouldn't have extra training material. We'd have very short shots. We'd have shots where you could be running, driving, in shadow, in light, turning your head, aging, getting beaten up, any of those things. And the process is robust enough to do that without requiring specialist training data. So there's no consideration required from on set or when the film is being made to make the process come off. And then similarly, when we're recording me in the sound booth, again, as I said earlier, we don't have to get specialist apparatus in there with complicated, synchronized whatever. We don't have to have the actors sitting in some kind of rigid head pose with dots all over their face and cameras hanging off their head. We try and keep it as natural as possible. We aim to pull off the process in a really sensible amount of time for a film production, and obviously in a budget that allows this at scale. So, as Daryl said, the whole idea is just to make this much more accessible for foreign films to a different market, and that wouldn't be the case if it was intrusive, incredibly expensive, or very time-consuming.
Right, exactly. And this is not just a challenge for your use case, but every use case of artificial intelligence, where you have to ask yourself, how much can we reasonably expect to disrupt an existing process with a promise of innovation before someone decides that they don't want to bother with it, right?
Yeah, I mean, it's that thing, isn't it? Like, you can get really excited by the tech and it works really, really well. And it works kind of theoretically. And look, I'm very fond of saying this because it actually happened. My father once said to me, Mike, you can read the entire works of Sigmund Freud, but son, sooner or later, you're going to have to take a girl on a date. And my attitude is, it's all very well for us to get this working in the lab, but it has to work in the real world. And the real world is not just a matter of, saying, oh yeah, if you did this, and this, it'll all happen. They're like, well, that's great, mate, but that's not possible. And we want to be, as I said, very respectful to the creatives involved. Would you want to do a film if you knew your face was going to be altered by technology that wasn't respectful of the performance you gave? No, you'd be as an actor, hey, I'm not doing that project, or I'm not allowing you to modify my face, because that is your reputation. If we modified your face and Rob, your original performance was spectacular, but our modified version was kind of believably realistic, but you just didn't look like you're acting very well, it would establish your reputation as a bad actor in a foreign market, and you'd never want that. So it's terribly important that we don't just come at this from hey, theoretically, somebody thinks this looks real. We have to be, hey, I didn't even notice that this was happening, and boy, Rob gave a great performance in that film.
Yeah, that makes sense. And by this point, we've all seen, speaking of auto-generated performances that the actor objects to, we've all seen the deepfake Tom Cruise videos. How would you differentiate what PLATO is doing from the mainstream understanding of what a deepfake video is?
Well, firstly, I'd say just to be clear, I don't think Chris, who did those videos, had any objections from Tom Cruise. As last I heard, and I've spoken to Chris, it was well received, and no, Tom Cruise didn't object to the process. So, and I think most people would agree that Chris's work on doing the fake Tom Cruises is entertaining, funny, and good satire. But it is a fundamentally different process than what we're talking about for two reasons. One, of course, is they replaced the actor's face completely with a synthetic Tom Cruise face. And so what you're getting there is the Tom Cruise full mask, if you like. We're not doing that. We're blending in so that it's, in this case, to use the analogy, it would be my face on your body if we were doing a face swap deep fake. But we're not. We're keeping your face on your face. It's just that you're mimicking my lip movements. And then the other big thing is Chris did a terrific job on those things, but they were taking him 10 hours or something to do a shot. We're going to need to plow through hundreds and hundreds of shots in a film, and we just can't afford that kind of bespoke curation that Chris has done such a great job on. So deep fakes tend to be satirical, and they tend to be crafted. And even if they're not crafted, they're a full face swap. The other thing to remember about that is most of those videos, if you actually analyze them, this isn't strictly totally true, but it's kind of pretty close, are straight to camera. So it's like Barack Obama facing the camera. It's like Arnold Schwarzenegger facing the camera. It's a Tonight Show host like Jimmy Kimmel or whoever facing the camera in a very evenly lit studio environment. Like when a politician's delivering a speech, when a Tonight Show host has got a guest on, they're very evenly lit and consistently lit, and they're facing the camera. Our process isn't like that at all, because we have a guy speaking in a foreign language while boxing and while people are hitting him in the face and running around. And we've got him at night, missing spotlights from guards. We've got him in the daytime on the work gang. We've got kids at the dining room table, and we've got children in the darkened corners of Auschwitz, nearly starving to death. And so that full range of lighting, angles, and action are really quite different from your demo, clever, standard, which are good, don't get me wrong, they're great, those deep fakes, but they're just a very different technical hurdle to jump.
When you explain all of the challenges there, what happens if someone is in different lighting? What happens if they're moving? What happens if they're being punched in the face, right? There's, a million more. There's the continuity of someone perhaps growing a beard or having changes to their face in the case of a boxer, certainly. These are it just gets more and more complicated and challenging the more you explain it. Are these additional ML approaches, or how are you sort of factoring in just the increasing complexity of this challenge?
Well, the good news here is that the team includes Pinscreen in Los Angeles. Now, Pinscreen is a group of incredibly brilliant researchers, and they're the core of our technical backbone. And they have been developing original machine learning algorithms, GANs, like a whole range of solutions to address these problems. So you're right, it isn't just one black box. Our, magic bullet, if you like, is the genius of the research team at Pinscreen. But their solutions are a concatenation of a series of specialist tools that are as automated as possible, but still require some, I guess we'd call it manual intervention, in the sense that, let me give you an example, and it isn't from our film, but when you're producing machine learning, the approach is often to say, more training data, better. And the guys at Pinscreen in our team clearly didn't have that advantage. They couldn't get tons of training data. They had to work off really, really short scenes, sometimes under a second long. So they came up with really clever ways of dealing with this. But if you just think about machine learning generally, yeah, most people would just say more machine learning, better. But you need to curate your machine learning for the training space that you want to establish, because the training material defines a training space within which you get the best training solution. There's another project that was done that we weren't involved with called Welcome to Chechnya. And in that project, the team that were doing that did a different process to us, but it was a splendid face replacement, like you were talking about before, like a deep fake face replacement process. But there they discovered that rather than just use all their training material, which quite often for them had the actor turning to the side to talk to the director, and they were just rolling the cameras, and he'd look to the side, talk to the director for 5 minutes, turn back, do a take, turn back to the director, hey, was that good? How was it? Etc. Thus causing the training data to be incredibly biased to one side of his face, because whenever he wasn't delivering a line, he was looking to the side. And they quickly established, well, yeah, it's heaps of training data, but it's all disproportionately showing one side of this actor's face. And so that project very quickly worked out that it would be really good to be able to curate through new machine learning processes. And so Ryan was the visual effects supervisor and the lead machine learning expert on that. Ryan did a spectacularly good job. And he's a dedicated documentarian who's keen to use this technology for, in this case, protecting the identities of LGBTQ community members who were in the film that would otherwise be persecuted if their identities were revealed. So a different problem. But in his work, he quickly came to the realization that, as in fact we did with a completely separate application, you need to be very specific about what training data you're using and when. And so there's a lot of smarts, a lot of good experience that is still added to the mix. So as automated as our process is, or any process is, you still really value having a really good machine learning expert driving things.
Of course, yeah. I'm going to ask you to maybe prognosticate a little bit here. What are some other areas of the entertainment industry you expect AI to be disruptive?
Well, it's a great question. And heck, I don't have any crystal ball, but there's a bunch of areas generally on the table that are already being kind of looked at. So one thing is very fine, temporally accurate segmentation, because with image segmentation on a still, okay, you get a lifted element out like you can in sort of various plugins for Photoshop or whatever. But in the film industry, what you want is a temporal version of that, where I would be separating you from the background instead of using a green screen. But it's not just getting a segmentation of you in a machine learning sense. It's then being able to effectively polygonalize, if you like, or spline that curve such that a artist can then tweak it. So if I've got 100 frames and it lifts you out, I can't have every version of the matte or the extraction be different and unrelated to the one that comes after it, because the director says, oh, wait, I'd like that edge pulled in. You'd need to have that feathered in and feathered out effectively over, 20 frames. And you can't do that if you're having to tweak it on a per frame basis. And so we call that rotoscoping. And so that's the holy grail. If we could get machine learning to provide a spline-based, editable, artist-friendly, temporally consistent segmentation, there's millions of dollars on the table. And so people are so keen to do that. It's a bit of a dull process doing it manually. And so if you could automate it, it would be spectacular. And then that leads into lots of other things like rig removal. For stunts, there's a lot of work with using what you were calling before, like deep fakes or neural rendering for face replacement, so that your stunt double, Rob, has your face on him when he leaps through the building and smashes through the glass, and you yourself don't have to do that. And yeah, so it's a bunch of things like that. The one for us that's really interesting, and we're starting to look at this with a few companies like, say, Respeecher in the Ukraine, is changing the voice at the same time we change the face. So to go back to our original example, it would be me voicing you, you're the actor, But in addition to your lips moving exactly like mine did, you no longer get my voice coming out of your mouth. You get a cloned version of my voice that sounds like you, delivering the words that I said. So we'd change audio and vision.
Nothing but opportunities for this tech to be disruptive, it sounds like. And
absolutely.
Listeners out there, if they are keen on a new application, they have their marching orders for the business that they should form. Mike, we are creeping up on optimal podcast length here. So at this point, I would just say thank you so much for being a part of the show and sharing your experience and expertise with me. This has been fascinating. I'm really, really pleased you joined me today.
Rob, it's been a pleasure. Thank you.
How AI Happens is brought to you by Sama. Sama provides accurate data for ambitious AI, specializing in image, video, and sensor data annotation and validation for machine learning algorithms in industries such as transportation, retail, e-commerce, media, medtech, robotics, and agriculture. For more information, head to sama.com.